In this exercise, we are given the angular position of a point on the ring of a wheel. And the angular position is given as a function of time. So the angular position, theta, as a function of time, is given as 2.4 t plus 4.9 t squared plus 1.6 t cubed. In part A of the experiment, we need to find the angular speed of the point at time t equals 2 seconds. So angular speed omega at time t equals 2 seconds. So in order to find that, we first need to find the angular speed as a function of time. So how does angular speed relate to the angular position? Well, just as we did for the linear speed, we can say that omega is equal to the time derivative of theta, d theta dt. So if we take the first derivative of this, what do we get? We get 2.4 plus 9.8 t plus 4.8 t squared. So now we are ready to put the number in. So we have 2.4 plus 9.8 times 2 plus 4.8 times 2 squared. So this is equal to 41.2 radians per second. So this is the angular speed at time t equals 2 seconds. In part B of the experiment, we need to find the average acceleration of the point from time t equals 2 to time t equals 5 seconds. So average angular acceleration, alpha, is equal to final angular velocity, omega final, minus initial angular velocity, omega initial, over the time interval delta t. We already know what is our initial angular velocity, that's 41.2. So we just need to find omega final, the final one, at 5 seconds. Well, again, we can use the same equation for omega. So we have 2.4 plus 9.8 times 5 plus 4.8 times 5 squared minus initial angular velocity, that's 41.2 over the time interval, which is 5 minus 2, so 3 seconds. If you now calculate for this, the value that you get is 43.4 radians per second. So that's the average angular acceleration over that time interval. And now we need to find the instantaneous acceleration at time t equals 5 seconds. Instantaneous acceleration is a time derivative of the angular acceleration. Sorry, angular velocity. So instantaneous angular acceleration alpha is the time derivative of the angular speed omega, so d omega dt. We take another derivative, so you get 9.8 plus 9.6 t. So the instantaneous acceleration at time t equals 5 seconds is equal to 9.8 plus 9.6 times 5. So this is equal to 57.2 8 radians per second squared. Here, by the way, we also have per second squared because this is acceleration.